Hi, we're Team 4 in the Fall 2018 section of the Capstone Design course in the Industrial and Manufacturing Systems Engineering Department at Iowa State University. For this project, we got Danfoss Power Solutions in Ames, Iowa, and our project was an assembly line redesign. My name's Jeff.
I'm Abdul.
I'm Kelsey.
I'm Tyler, and here's a brief overview of our project for this semester.
Danfoss Power Solutions specializes in building hydraulic pumps and motors for off-highway vehicles. One of the many assembly lines in this facility is called the MDM assembly line, or medium-duty motors. This assembly line builds small to medium-sized motors and was brought to Ames in the late 1990s. The equipment is old and some is obsolete, resulting in increased downtime.
The goal of our project was to redesign the assembly line to meet the following objectives. First, increase the capacity of the assembly line by 22% to meet the demand projections of 2023. Second, increase the operator efficiency for the ideal staffing design to 88%, whereas the variable staffing design efficiencies need to be greater than 80%.
For the analysis of the current state, the team used the following industrial engineering tools to evaluate the assembly line. First, the team used observed time studies to create the line balance charts and to calculate the capacity and capability of the assembly line. Next, the team analyzed the production data from the hour-by-hour reports to quantify the downtime the assembly line experiences. This data was also used to validate the assumptions of the project. Lastly, the team completed ergonomic assessments of the line in human tech to identify safety concerns that could be eliminated in the future state design. One of the major discoveries in the current state was the amount of downtime experienced by the assembly line. During the first 8 months of 2018, the assembly line lost approximately 12,000 units. We found that the top 4 downtime contributors included the test stands, part shortages, the paint system, and part quality concerns. The other major discovery in the current state was the capacity constraints of the assembly line. Shown in the figure on the left is the operator balance Danfoss uses when 6 operators are staffed on the line. This balance produces a capacity that is approximately 52% of the 2023 demand projection and has an operator efficiency of 57%. The chart on the right shows a different operator balance for 6 operators. This balance produces a capacity that is 59% of the 2023 demand projection and has an operator efficiency of 65%. As a result, the operator balance on the right is preferred because of its higher capacity and operator efficiency.
The discoveries from the analysis of the current state were used to brainstorm improvements as well as identify equipment upgrades for the future state of the assembly line. After these were identified, the work content was analyzed and redistributed to provide a better line balance and reduce the bottleneck time to meet takt time. Lastly, the team created the operator balance charts based on the redistributed times. Shown in the figure on the left is the ideal operator balance. This balance uses 9 operators and 2 robots to produce a capacity that is 102% of the 2023 demand projection and has an operator efficiency of 84%. The chart on the right shows the variable operator balance. This balance produces a capacity that is 97% of the 2023 demand projection and has an operator efficiency of 76%. The ideal staffing design is intended to be used when the demand meets the 2023 demand projection. However, the variable staffing design can be used in the interim until demand meets projection. The top figure represents the current layout of the assembly line. As seen, there are 6 assembly stations with 2 test stands. Out of those 6 stations, there are 3 ergonomic concerns related to part manipulation. The bottom figure represents the layout of the future state of the assembly line. As seen, there are 2 robotic stations, 7 manual stations, and 2 test stands. The ergonomic concerns related to the part manipulation from the current state were engineered out of the future state through the use of robotics and a new pallet design concept that can handle all the work content without transfer to substations.
Danfoss's selected course of action for this project was to go with our recommended alternative of an automated assembly line redesign. The investment for this project is $5 million including automation, and the average annual benefit is $1,665,000. These benefits are from meeting demand, eliminating overtime, reducing downtime, and eliminating the need for premium freight. The total 5-year net present value of this project is $790,000.
We would like to thank Danfoss Power Solutions in Ames, Iowa, along with Iowa State University, for the opportunity to complete this project as well as expand our industrial engineering tool knowledge. We would also like to thank you for watching.